Hello students, welcome back to my YouTube channel Complex Biology. So in today's lecture, we will learn the same thing which we learned in the previous lecture, that is how to determine the charge, the net charge on a peptide at a particular pH. So for knowing the basics, please watch my previous video. So today we will continue straight away with how to determine the net charge on a peptide at a particular pH. So we know it very well that when we find out the net charge on a particular peptide at a particular pH, that time apart from finding out the charge on the side chains, we also find out the charge on extreme left and right of the polypeptide. So like in extreme left there is NH2 amino group, and on extreme right there, like this is NH2 group, it will be there only on the extreme left. In between there will be no NH2 group because amide bond is formed, so it disappears. And on the extreme right we have got COH group. So apart from finding out the charge on the side chains, these side chains, we need to consider charge on this and this as well. Now the given peptide is glutamic acid, glycine, alanine and lysine. Now we know glycine does not have any side chains, right? Glutamic acid has this side chain, glycine does not have any side chain, alanine has CH3 group, which is it is aliphatic. It does not have any functional group, so it also does not have any charge. But lysine has this side chain with a charge, right? So, and this COH group is also chargeable, ionizable. So we will find out one by one. We will find out the charge on first of all NH2, then this COH, then this NH2, then this COH, right? So now we know the rule, and this peptide is kept at pH is equal to 1. Now we need to find out the net charge on the peptide. So we will start with NH2. Now we know the rule very well that pKa, if the pH is higher than the given pKa, then that means if pH is higher, that means there is a scarcity of H plus ions. Like the medium is less acidic, that is, it is basic. So since medium has a lack of H plus, so that's why in order to establish the equilibrium, the H plus is lost from the side chain. So in this case, we all know that the rule already. H plus is lost. But in case the peptide is kept at lower pH, then H plus remain accepted. Right? Now let us consider our case. First of all, we will find out for NH2. We know that the pKa of this group is around 10. Almost 10 or 10 point something. And what is the given, at what pH the peptide is kept? It is at pH 1, which is lower than pKa. So this is 1. Now we know the pH is lower as compared to the pKa. So in this case, H plus will remain accepted. So here it will accept what? H plus. So it will become NH3 plus. So charge is plus 1. Now the next thing is, now we need to consider this side chain. Now we know the pKa of side chain of glutamic acid is 4.25. written it over here. It is 4.25. Again, this peptide is kept at pH is equal to 1. Now it is again lower. So in this case, H plus will remain accepted. Otherwise, like this is the. So here H plus is lost. But since pH is lower, so H plus will remain accepted. So it will be COH. So the charge will be 0. Now here, this side chain is non-ionizable. Now we will consider this one. Here I have already written the pK. It is 10.53. 10.53. Right. And pH is again lower. So in this case, again H plus will be accepted. So it will become NH3 plus. Now we will consider this COH. So the pKa of alpha COH is how much? It is around 2 or 3. Sorry, 3 to, in between 3 to 4. So let us consider it is 3. Again, it is kept at low pH. So H plus will remain accepted. So here charge will be 0. Now, since we want to calculate the net charge, now it's time to calculate the net charge. So now simply we will apply simple maths. So net charge will be plus 1 plus 0 plus 0 plus 1, which is plus 2. So that means if we will keep this peptide at pH is equal to 1, then the net charge on this peptide will be plus 2. So that's how we can find out the net charge on the peptide very easily. Hi, so now let us consider this polypeptide. Glutamic acid, methionine, arginine, threonine and glycine. Now we already know from the last peptide, the pKa of glutamic acid is, this thing is 4.25, right? And arginine, it is a basic amino acid, and the pKa of the side chain of, this is the side chain of arginine, it is 12.48. And methionine, threonine do not have, they have side chains, but their side chains are non-ionizable. So I'm not showing their structure because it will unnecessarily complicate the things. Because we are only concerned with this one, this and this. Because these are the only ones which are ionizable. Now, this polypeptide is kept at pH is equal to 7, that is neutral pH. Now we need to find out the net charge on this polypeptide at pH is at neutral pH. Now we know that NH2 group when accepts H plus, it becomes NH3 plus, whereas COOH when it loses H plus, it becomes COO negative and H plus. Now let us, for ease, let us write the law over here. This is pKa, right? And if it is kept at low pH, then H plus remains accepted. See, I'm writing it over here for ease. Otherwise, if you can remember the rule, then well and good. There is no need to write it. But we tend to forget things. So it's always better to write the rule. When it is kept at high pH, then pKa, then H plus is lost. Right? Now let us consider one by one. 7. Here pH is 7 and pKa of side chain is almost 10 of NH2 on the extreme right, or I'm so sorry, the pKa of NH2 group on the extreme left is almost 10 and the pH at which it is kept is 7, right? So now, since this pH is lower, then H plus will remain accepted. So we know that NH2, when it accepts H plus, it becomes NH3 plus. So it will become NH3 plus. So the charge is +1. Right? Now we will consider this side group, this side chain. So it has got alpha, beta, gamma, gamma COH. So the pK is given 4.25. 4.25. But now in this case pH is higher because pH is 7. This peptide is kept at pH 7. So now in this case, rather than being accepted, H plus will be lost. So it will be lost. So it is -1 here. Right? Now we will find out for this one. So the pK is 12.48. 12.48, and it is kept at lower pH 7. So H plus will remain accepted. So it will be NH3 plus. This is +1. Now we are only left with this ionizable group COH. So the pK is almost in between some 2 to 4. So even if we consider the pK as 4, still the given pH at which it is kept is 7. So the pH is 7, which is higher. So in this case, H plus is lost. Right? So it will be minus. So now the charge is minus. So now we will find out the net charge here by simple mathematical calculations. Net charge. So it is +1, +1, -1. This is +1 and this is -1. So it is 0. So that means if we will keep this polypeptide at pH is equal to 7, that is at neutral pH, then the net charge on this polypeptide will be 0. Hello students, so now we will learn how to find out the PI or isoelectric point on a particular peptide, not on amino acids. Amino acids we did already. In my last video, prior to this video which I made, you can check how to find out the isoelectric point of a particular amino acid. But this time we will learn how to find out the PI or isoelectric point of a particular peptide. These kind of questions are actually a little bit complex, and we will make use of all the concepts that we have learned so far. But because these are very complex, so even CSIR won't ask these kind of questions. For CSIR you may skip these kind of questions. You don't need to study that much. These kind of questions are only meant for those students who want to learn more and more about a particular subject, and those who are extremely curious, just like me. So now let us find out the PI or isoelectric point of a peptide with glycine, aspartic acid and glutamic acid as their amino acid. So now if we want to find out the isoelectric point or PI. Isoelectric point or PI of this particular peptide. Then one by one we will keep this peptide at pH 1. Then we will find out the net charge at pH 1. Then at pH 2. Then we will find out the net charge at pH 2. Then pH 3, pH 4. Net charge of all these pH. Then we will find out where exactly the net charge is 0 at which pH. and then we will the pH at which the net charge is 0 or near to 0. At we will consider that pH only, and after considering that pH we will find out pKs. Out of these pKs, which two pKas are on the right and the left side. I mean greater, just a little bit greater and just a little bit smaller than that particular pH. Then we will take the average, and that will give us the value of Pi. So now let us, actually by saying all this you won't understand. Let us do it one by one. First of all, we will make this structure. So this is the structure of this peptide. Now we know this rule. If pKa is like, if pKa is 2.10, first we will consider for this, because this peptide has alpha COH, alpha NH3, NH2 or NH3. It has pKa3 as aspartic, the side chain of aspartic acid and the side chain of glutamic acid. So these are the only ionizable groups in this particular peptide. So we will first we will keep this peptide at pH 1, and then one by one we will find out the charge, and then after the net charge, like we did in the previous video. So at first of all consider at pH 1. So COH, it has pKa, alpha COH has pKa 2.10. So now we have kept this peptide at pH 1, which is lower than pKa of this COH. So that means H plus will remain accepted. So if H plus will remain accepted, it means that when H plus is lost, as we already know, it looks like this, right? But in this case, H plus will remain accepted, so the charge will be 0. Now we will consider for alpha NH, NH2. Now the pKa, I have written the pKas over here, 2.10. Now we will consider 9.78, because we are looking at alpha NH3. So at pH 1, again the H plus will be accepted because the pH is lower than the pKa. So when it will accept it, then it will be plus 1. It is NH3 plus. So the charge will be plus 1. Here the charge was 0. Plus 1. Now we will consider for pKa3, 3.86. Again, the pH at which this peptide is kept is 1, which is lower. So H plus will remain accepted. So it won't ionize like this. It will remain accepted. So it is 0. Again, for pKa4, which is glutamic acid, 4.97. Right? It has 4.97. 4.97. Again, pH is lower. So COH will remain accepted. So the charge will be 0. So on this 3.86 the charge was 0. Here also charge is 0. So the net charge is plus 1. Right? We will add all of these, 0 plus 1 plus 0 plus 0. So it will be plus 1. So that means if we will keep this peptide at pH 1, then the net charge will be plus 1. Now let us do for what happens. Now let us see what happens when this particular peptide is kept at pH 2. Right. Now again we will consider one by one. For alpha COH, it is 2.10, right? So 2.10 is greater than this pH. That means it is kept at low pH. So H plus will remain accepted. So it will be again 0. Again for this one also, zero. Here it is 0. For NH3 plus 9.78. it is again at low pH, so H plus will remain accepted, so the charge will be plus 1. Now for 3.86 also, the pH at which it is kept is 2, which is lower than 3.86. So COH will keep the H plus accepted. It will be 0. Then again for 4.97 also, it will be H plus will remain accepted. So here also the charge will be 0. Again the net charge is plus 1. Now let us consider for pKa at a pH 3. We have done 1, 2, now 3. So now pKa is 2.10. But this time it is kept at pH 3. So here pH is higher. So in this case now H plus will be lost. So since H plus will be lost, so it will be like this, minus. So the charge will be minus 1. But for rest of the others, the pH is low, because all other pKa's are greater than 3. So for 9, let me write it over here first. For 9.78, it will remain accepted. So it will be plus 1. For 3.86 also, here NH3 plus will remain, will accept the H plus. For 3.86, COH will remain like this. It won't lose H plus. It will accept the H plus. So 0, here 0. For 4.97, also it is 0, because it is also 0. So that means here now the net charge is 0. So that means this is the pH. I told you earlier, we will find out. Let us first find out for all other pH. Then we will discuss how exactly we will proceed. Now let us calculate at pH 4. So pKa for alpha COH is 2.10 and it is kept at pH 4. So now H plus will be lost because pH is higher. So it will be minus 1. For this we are calculating for alpha COH. Right? So but for this one, alpha NH3. Now, since pKa is 9.78 and we have kept it at 4 pH, which is lower. So now H plus will remain accepted over here. Here it is minus. Minus. Right. Sorry, it is plus 1, not minus. Now we will consider 3.86. But the pH at which this peptide is kept is 4. So now it is lower. Sorry, it is higher. So H plus will be lost from here. From 3.861. So here charge is minus 1. But at 4.97, the lower pH is lower, which is 4. So H plus will remain accepted. That means the charge on this one will be, here it is minus 1. On this one it is minus 1, but on this one it will be 0. Now we will take the total, so it will be minus 1. Similarly, we can find out the charge at each other pH. Then we can continue. Since it is not visible due to flash, so I have written it over here also. So now for other pH, I am writing them directly, because I hope you can find it out yourself. So at pH 5, the net charge will be -2. At 6, -2. 7, -2. At 8, -2. At 9, -2. And at 10, pH 10, the net charge on this peptide, polypeptide, will be -3. Now, I told you about the rule. We will find out the charge on a particular peptide at all the pH. Then we will look at the net charge. These are the net charges, right? And we will find out the pH at which net charge is approaching 0 or it is 0. So we can see that at pH 3, the net charge is 0. So that's what we want. We were looking for that, but this pH only, at which the net charge is either 0 or approaching 0. So now we know that at pH is equal to 3, the net charge is 0. But there are so many other pH also in between 3 and 4, where the approximate charge can be 0. So like at 3.1, 3.2, 3.4, 3.5. So we need to consider those pH also. We know that at 3 it's 0. But in between also there are so many other pH. So we will find the most closest and approximate value. So now we will consider at pH 3.8. So first of all we will consider for alpha COOH. So the pK is 2.10. However, pH is 3.8. We have kept the peptide at 3.8 pH, right? So the pH is high. So H plus is last. So it will be -1. Now for alpha NH3, pK is 9.78 and pKa for this pH, which is 3.8, it is lower. So again, it will remain, the H plus will remain accepted for this one. Now we will look at 3.86. Right? Again, it is kept at pH 3.8. Still it is lower, and since it is lower, the H plus will remain accepted. So charge will be 0 at for third ionizable group, which is aspartic acid side chain, and for pKa 4.97. pKa 4.97, the pH at which it is kept is 3.8. So again, it is lower, so it will remain accepted. So now here also the charge is 0. But if we will do at 4, the charge is -1. So that means the most approximate and the most closest value at which pH is 0 is 3.8. So this is the pH which we are looking for. pH 3 also gave us an idea of what could be the approximate pH. But 3.8 is like much closer, where the net charge is approaching 0. Now we will consider the pKa's which are most closer to 3.8. So 3.86 is very close to it. So we will consider this one, and 4.97 is also very close to 3.8. Right? Others are far away from this one. So we will take the average of these two pH, and the average of these two pH will be the isoelectric point for this polypeptide. So let us do the total. Let us do over here 3.86 plus 4.97. So it is 3.86, 4.97. 8.83. So we will take the average, which will be this is 4.07. So it will be not 97. .86 plus 4.07. This is not 97. This is 07 actually. So 7.93. Now we will take average of this value. So 7.93 divided by 2. So 3.96. So the isoelectric point of this polypeptide is 3.96. So that is the answer. So these kind of questions are a little bit complex, but to understand more, these are the best kind of questions to clear the concept and to know more and more. So the another example I'm not doing today, we will do some times later. So till then you can keep on practicing these kind of questions. In another one in which we will be calculating the PI, we will consider a very large peptide. Not very large, like more than a peptide which has more than 3 amino acids, like 4 or 5, right? So we will do that later. Till then, you may go ahead and practice these kind of questions. Thank you so much.